The first section will discuss the area of a triangle. Definition, altitude, and base. An altitude is a segment from a vertex of a triangle to the opposite side and is perpendicular to that side. The altitude is the height of a triangle. A base is the side of a triangle that is perpendicular to a given altitude. Area of a triangle. The area of a triangle is found using the following formula. A equals 1/2 BH, where B is the length of the base and H is the height of the triangle. The next section will discuss the area of a quadrilateral. Area of a square. The area of a square is found using the following formula. A equals S times S, where S is the length of the side of the square. Area of a rectangle. The area of a rectangle is found using the following formula. A equals L times W, where L is the length and W is the width. Definition, base of a parallelogram. The base of a parallelogram is the side that an altitude of a parallelogram is perpendicular to. The length of the altitude is the height of the parallelogram. Area of a parallelogram. The area of a parallelogram is equal to the product of the base and the height. A equals B times H. Definition, bases of a trapezoid. The bases of a trapezoid are the parallel sides of a trapezoid. Area of a trapezoid. The area of a trapezoid is found using the following formula. A equals 1/2 times H times quantity B sub 1 plus B sub 2, where H is the height and B sub 1 and B sub 2 are the bases of the trapezoid. Example, area of a trapezoid. Find the area of the given trapezoid. Solution. The figure shows that H equals 8, B sub 1 equals 12, and B sub 2 equals 18. Substitute these values into the area formula to get A equals 1/2 times 8 times the quantity 12 plus 18. Simplify to get A equals 120. Area of a rhombus. The area of a rhombus is half the product of its diagonals. A equals 1/2 D sub 1 times D sub 2, where D sub 1 and D sub 2 are the lengths of the diagonals. Area of a kite. The area of a kite is half the product of its diagonals. A equals 1/2 times D sub 1 times D sub 2, where D sub 1 and D sub 2 are the lengths of the diagonals. The next section will discuss the relationship between perimeters and areas of similar figures. Perimeters of similar figures. The ratio of similarity of two figures is equal to the ratio of two corresponding sides of the figures. The ratio of the perimeters of the two similar figures is the same as their ratio of similarity. Example: perimeters of similar figures. The ratio of similarity of the two figures is 3. The perimeter of figure 1 is 17. What is the perimeter of figure 2? Solution: the perimeter of figure 2 equals the ratio of similarity times the perimeter of figure 1. Substitute the given values into the equation to get 3 times 17. The perimeter of figure 2 is 51. Areas of similar figures. The ratio of the areas of two similar figures is the square of their ratio of similarity. Example: areas of similar figures. The ratio of similarity of these figures is 4. The area of figure S is 5. What is the area of figure R? Solution: the area of figure R equals the ratio of similarity squared times the area of figure S. Substitute the given values into the equation to get 4 squared times 5. Simplify to find the area of figure R is 80.